I'm going to talk today about how normal is the normal curve. We see it all the time, and people try to convince you of things with statistics all the time. The bell curve is ubiquitous. You see it everywhere. Now, I'd like to start off with a couple of questions. What was the highest temperature ever recorded on Earth? When was it? Where was it? How high was it? Your guess? It was 56.7 degrees centigrade, 134 Fahrenheit. It wasn't in the Sahara. It was in California in 1913. People, statisticians with a story to tell don't want you to know that. They will show you this from this year, 2023, showing 133 degrees in Furnace Creek, California. No, the actual high temperature in Furnace Creek was 128. They were hoping for a new record, but they didn't get one. But they showed it on the news anyhow, as if it were, and you might believe it was. Here's another one. There was the hottest week in U.S. history. Broke all records. Every state in the United States recorded a temperature over 90 degrees. That's 32 degrees Celsius. 40 recorded temperatures over 100. That's 38 Celsius. And 16 recorded temperatures over 110. That's 43 Celsius. Okay, what year was it? Zip, it was 1933. California recorded almost 50 degrees Celsius. That's not what you've been led to believe, is it? Statistics are a funny game. Statistics support arguments about all sorts of things. Warming, overpopulation, intelligence, childhood vaccines, and the COVID vaccines. And they always have a story that they want to tell you, so you should question who's showing you these statistics. The global warming people are selling, making tons of money from electric cars, windmills, solar power, carbon trades, and so on. A lot of money in that. Be careful what they're telling you. What about overpopulation? There's scads of do-gooders making a good living off of the overpopulation scare. Actually, the population seems to be going down. How about intelligence? The do-gooders are trying to flood your country with people from all over the world saying that we're all the same, regardless of where we're from, what we look like. That's not true. Intelligence researchers have known this for 100 years. They don't want you to know it. And then I told you that the job is safe and effective. Most of you know that that's not true. And they've been telling us for 100 years that they are safe and effective. We'll question that also. Cases of autism in the United States were 1 in 10,000 when I was a kid. Heck, they were 1 in 10,000 when I was 30 years old. Now they are officially, according to the Centers for Disease Control, 1 in 54. And people think it's more common than that. There are places where it's 1 in 10. What caused it? Well, we noticed that the incidence gone up right in parallel with the cases of autism. They say that there's no cause. Well, what could it be? Now here's the vaccine schedule for children in the United States. 30 of them by the time they're 15 months and another 30 by the time they're 18. When I was a kid, it was 8 altogether. It's gone up significantly. And here's another graph. This is one produced with government statistics that they don't want you to see. In the United States, there are 50 states. They don't all follow this Centers for Disease Control's recommendations. Some of them recommend only some of them. And this is a correlation here between the number of that are required by a state and the incidence of childhood deaths, kids who die. Funny thing, the more you get, the fewer deaths you should have, but that's not what you see. They require, the more kids die. They don't want you to see that. Let's flip back to the weather. This is a plot of 100 years of daily temperatures, 36,500 dots. And you see that the dots follow a pattern. It's hotter in summer than winter. I think you knew that. And at any given day, this is August 12th, looking over 100 years, you see the dots scattered in a very predictable pattern. It's called the bell curve. This is the bell curve. With any collection of dots, if it's normal, if it follows the bell curve, it has an average, which for Kiev in July was 25 degrees, and it has a standard deviation. How much wiggle is there from the average in the average day? And in Kiev, that's 3.5 degrees centigrade. So by the bell curve, we could say, with reasonable certainty, that we expect 2/3 of the temperatures to fall between 21.5 and 28.5 degrees. That's 3.5 degrees of the median. And we expect 95% to fall between 18 and Celsius. That's just the projection. Based on what we saw in July, that's what we would expect going forward. The bell curve is used both to describe what has been and what we expect will be. It's used another way. In a time series, it's used to say what is the expected difference from one period to the next. For instance, what's the expected jump in the stock market from day to day? And in this case, I just chose one. What is the expected change in the percentage of the U.S. population in the workforce from year to year? Now, this is a 70-year graph. And what you see is it goes up and down. It went up until 2000 as women entered the workforce. And it has gone down since 2000 as, number one, the population has gotten older and doesn't work as much. And number two, men have gotten discouraged and left the workforce. So here's a graph of the same thing looked at in a different perspective. What is the year-to-year change in the percentage of people working? And this is very subject to statistical analysis. And what you see is that it goes up and down. The standard deviation is 0.6%. In other words, 2/3 of the time, it doesn't wiggle by more than 0.6% in a year. 95%, it doesn't wiggle by more than 1.2% in a year. And of course, there are exceptions like 2022, when COVID came along. A lot of people left the workforce, but they came back the next year. That's what you see on the right. Another example. You wouldn't think these were related, but they are. Flipping a coin follows the bell curve. You probably didn't know that. If you flip it once, it doesn't look like a bell curve. It's heads or tails. If you flip it twice, you got 3 outcomes. 2 heads, 2 tails, or 1 of each, but that's twice as frequent. 3 outcomes, you got all heads, all tails, or 3 and 2, both ways. 8 outcomes. And this is how it looks as you go. It starts to look like the bell curve. Let's move the bell curve over so we can see better. That's 2, that's 3, and now that's 5. Oh, that's starting to look like a bell curve. That's 7, it's looking more like a bell curve. That's 10. Well, my goodness, it's starting to look like a bell curve. 20 and 40, and we're almost there. Yes, the binomial distribution, Pascal's triangle, does look like the bell curve in the extremes. So the bell curve is more common than you thought. And if you use a loaded coin, it does the same thing. Let's say you have a coin that comes up heads 2/3 of the time. You want to cheat. That also describes a bell curve, more or less. It's not quite symmetrical, but almost, and it's just shifted over. So the center is 1/3, 2/3, exactly what you'd expect. Let's look at a practical example of this. According who's of finance technologies, he has a book out, Cause Unknown, the sudden death episode. He talks about disabilities. The disability rate in the United States is 9 per 1,000. That means that more people that 9 people out of 1,000 are receiving money from the government because they can't work, and that rate that's his story. So this is like a coin flip shifted way over to the left, and if you give 1,000 people, none of them could come up sick, and maybe 13 or 14 of them could come up sick, but the most likely number is 9. Now here's another thing. If you give it to 1,000, you get a flat curve like the blue in here. In other words, you might get 1, you might get 13, and you couldn't really tell the story, say they had an impact. But when you give 10,000 people, then you get the tall curve there, with the center at 91 out of 10,000. And it's a much narrower curve, so you can say, yeah, that looks right. And if somebody tries to tell you that it's only 40 out of 10,000, you could say, that doesn't look very likely. That's not what the curve looks like. So big numbers are important in this game of bell curves. So what's my conclusion? First of all, the model repeats itself. The bell curve is ubiquitous, shows up all over the place. Shows up in the bell curve itself, it shows up in the coin flips, and it shows up in the skewed distributions, one of which is called the binomial distribution. That's if you have finite number of flips, and the Poisson distribution, which is just a smooth representation. It's only a model. It's useful. It may be useful for describing reality. It never exactly describes reality, and especially the tails, the extremes, are not there. For instance, as I mentioned, the weather, it would be extremely rare for us in Kiev to get a 40-degree Celsius day. We will never get a 45-degree day, even though it might show up out on the tail of the bell curve. It's just simply not going to happen. It's useful. It is never totally accurate, but it's useful. And lastly, if your model doesn't fit the bell curve, it's time to question your model. If I tell you then you say, how does that square with the fact that the highest temperature ever recorded on Earth was 110 years ago, and the hottest week in United States history was 85 years ago? Something isn't right. I'm not going to say it's wrong. I'm just going to say you should ask questions. And that's my final message. People will try to lie to you with statistics all the time. There's a lot of money in it, as I said, a lot of money and power, and everybody likes money and governments like power. So if somebody comes to you with statistics, you should ask, what's their agenda? What are they trying to tell you? Why are they trying to tell you? And if you can, look for independent sources for counter arguments to the statistics you're being presented. Don't just take whatever they tell you and run with it. That's my story, Madam Toastmaster.